All right, well, now that everyone's got their It's in the System books and we are ready to begin the very first lesson, um, this is the last book we are going to get into this year. It's in the System, kind of talks about, in the past we've talked about just having one um, solving linear equations, just one equation at a time. Now we're going to start getting into two. So our focus question today is going to deal with how is the solution for a two variable equation different from a one variable equation. So here is just basically a one variable equation. It's an expression. We're solving for one variable, which here it would be x. All right. As you can see here, this proportion, and when we have a variable on both sides. And what we're going to kind of get into today is kind of more of what this equation is, having two variables at one time, which we know to be a linear equation. All right, so the worksheet you've been given for part A, it says read the scenario on page 8. So open your books to page 8, and it says try the combinations in part A, 1 to 3. Do they equal 600? Use the pattern of your calculations to answer question A number 4. Use T for the number of t-shirts and C for the number of caps. So we're going to zoom over here to our board. I'm going to shrink this for a minute because we won't need this right now, and we'll make this bigger. All right, so if you look at your books on page number 8, it does have a very similar picture for you, but it says the 8th graders are selling t-shirts and caps to raise money for their end of the year party. The profit from the fundraiser depends on the number of caps and the number of t-shirts sold. And here you see the profit picture there with the big whiteboard. You can see it's shrunk for you there on your paper. All right, so we've been given 15 t-shirts and 10 t-shirts or caps, 12 and 20, 30 and 50. And it's our job to take a look at this. So here's what I'm going to ask you to do right now. If we could pause this video. I want just part A. I want to give you guys about 5 to 7 minutes to just work on that, and I want you to fill in that table for the profit per t-shirt using that chart to your right, profit per cap, and total profit, and see if you can come up with a little expression, and take about 5 to 7 minutes. So make sure you work together on this. So go ahead and pause the video. Okay. Well, now that you've had a few minutes to work on this, we're going to blow this back up here, and we're going to see what you've come up with. Well, we know the t-shirts cost how much? Well, if you look over here, it costs $5 per t-shirt. So basically the profit for the t-shirt is 5 times 15, which is $75. Okay? And the caps, you can see over here, they make $10 profit per cap. So if they sell 10 hats, 10 times 10 is $100. So total profit, if we add up both cells, is going to give us $175. Okay, moving to the next one. If they sell 12 t-shirts, okay, at 12 t-shirts, at $5 per t-shirt, 12 times 5 is $60. All right. If we sell 20 hats at $10 a hat, 20 times 10 is $200. So 60 plus 200 would equal $260. Okay. Hopefully we match up so far. What if we sold 30 t-shirts and 50 hats? Well, 30 t-shirts times $5 per is $150. And 50 caps at $10 is $500. All right, so 150 and 500 is $650. Okay. So what are we going to try to come up with here for an expression? Well, the profit per t-shirt, t-shirts is T. We make $5 a t-shirt, right? So by doing that, it should be 5T here as our expression. Okay. And we make $10 per cap, so that's 10C. And whether you have a dollar sign here or not, so what is our total profit of expression? Well, it's $5 per t-shirt plus $10 per cap for the number of caps. And that is our expression for number 4 there in part A. All right. So again, just trying to establish what we're coming up with here. There's a lot to build off of here. This is going to be a fairly long lesson, so we may go into the end of the first hour and then the beginning of the second hour. or might have to pause this video during the break, that's okay. So moving on. All right, so for the next order of business is Part B. Well, in Part B it says, identify at least 5 combinations of shirts and caps that could produce a profit of $600. Okay, so we get to our total calculations on the far right, okay, on this box over here. Everything should add up to $600. So this is going to take obviously a little longer. So I want each group to come up with take about 15 minutes. We're going to pause the video again, but take about 15 minutes. If it takes less, we'll just start the video sooner. All right. But I want you to take some time and have each group work together, and I want you to come up with the 7 possible combinations. I'm sorry. There's 7 boxes there, but I want you to come up with at least 5. Okay. So the first 5, that leaves 2 unguarded, and I'll kind of fill these in from what I have on my key, and we'll see if you're missing anything. But we're going to work on this together and kind of fill it in. So each group, I want you to take some time, work together, and I want you to come up with at least 5 combinations of shirts and caps that give you $600 on the button. All right, so go ahead and pause this. All right, so now that you've had ample time to work on this, we'll blow this back up so we can see it a little bit better. All right. So one of the more common ones that I get is 0 and 60. Okay. 0 and 60 is an intercept. So we know that the profit per T-shirt is $5. So 0 times 5 is 0, and it's $10. Remember, it's $10 per cap, $5 per T-shirt. So at $10 per cap, that's $600. Okay. So again, we know if we plug this in, 5 times 0 plus 600 times 10. Actually, I probably got that written backwards. It's 10 times 60. This is 0 plus 600, which gives us $600. And again, that's the key we want to hit every single time. Okay. Now again, don't forget mine may be different than yours, and that's okay. You may have some different combinations. There are lots of possible answers here. So don't let the fact that any of these numbers that I put up here is wrong. And again, if you only came up with 5, you got 2 spaces. You can write a few of these underneath. Here's another one. All right, 72 times 5 is $360. And 24 times 10 is $240. And again, if I show that, all right, 5 times 72 plus, this is 10 times 24. All right, 5 times 7 is 3. So you got 360 plus 240, and that equals $600. So there's another point that falls directly on the line that we're working with. All right, here's another point. I'm trying to find ones that most people will get. Here's another intercept. Okay. The first one we had was a Y. This is an X intercept. Well, 120 times 5 is 600. This is 0. So 5 times 120 plus 10 times 0 is 600 plus 0, which gives us $600. Okay. Here's another one, 60 and 30. Okay, 60 times 5 is $300. 30 times 10 is $300. All right. So again, when I put this on the board, 300 plus 300 gives us $600. So hopefully you're finding a few, and hopefully some of ours match up. All right, here's another one, 70 and 25. All right, 70 times 5 is 350. 25 times 10 is 250. All right. So 350 plus 250 is $600. Okay. So most of you probably have stopped here. That's fine. But here's a couple more that I found. 30 and 45. Okay, 30 and 45 gives us 150 and 450. All right. So 150 plus 450 is $600. All right, so that's good. And then 10 and 55. Um, 10 times 5 is 50, and 55 times 10 is 550. So 50 plus 550 is $600. So again, what do all these points have in common? They all equal $600. That means that these points make our equation true. And as you can see just under this table, this is our expression. Okay? Plotting our solutions. So we can take, if we scroll down here a little bit, okay, we can take all these points that we came up with. 0 and 60 for the t-shirts, which is X, the caps is Y. So all those points in our table, we can plot these. Okay, and don't forget, when we write these as a coordinate, there's a comma here, right? So I got 70 and 25. I got 120 and 0. I got 30 and 45. And 10 and 55. So those are all the points that we came up with on our chart above. We put them in our little table down here. And then if I go ahead and plot these, we'll add 0, 60. Okay, it's a little off, but it's pretty close. All right. And I'll just kind of work my way in order. At 10, we're at 55. Well, this line here is 50, so 55 is about right there. All right, and then the next number in order, so that was this one and this one. I'm going my smallest x's first. So we got the 30, 45. So at 30, 45, we're about right there. Okay. The next smallest one is 60, 30. About right there. The next one we got is 70, 25. And then we got 72, 24, which is a tough one to show. It just passed 7. It's going to almost look like it's touching here, but it's not. And then the last one is 120, 0, which is right there on the x-axis. So again, you need my ability to draw straight lines. If I've connected these dots here, we should have a pretty nice straight line that, but you get the idea. It touches the line here. That's terrible. So graphing those points, you see that all these points here in this scenario, this is a linear expression. Okay? This is a linear line. We only need to show it in quadrant 1 because we're showing the profit. Okay? Number of t-shirts sold versus the number of caps sold. All right, to reach a certain number. So it says, how is the equation of a two-variable equation different from a one-variable? Okay, well, obviously, number 1, it has two variables, x and y, as opposed to one with just an x. Okay, and then here's the biggest one, number 2. Okay, a one variable has only one solution. And then a two variable has multiple solutions. Okay? And that's a big difference. Okay? In a one variable equation, there's only one possible number x can be, and that's just basically becomes a point. In a two variable equation, now you're talking about a line which can have an infinite amount of points. Okay? Now again, it says here the question, why doesn't the graph use quadrants 2, 4, and 5? Because you can't have, we're talking about number of t-shirts sold, right? You cannot have a negative t-shirt or cap, okay? So it just doesn't make sense to the situation. So you can't have a negative t-shirt or cap. Profit can go negative, but the actual quantity of t-shirts can't. So it just doesn't make sense to our scenario. So one thing to look at too, we have an x-intercept and a y-intercept on here. Okay, this point right here is an x-intercept. Why is it an x-intercept? Because y is 0. When y is 0, this is an x-intercept, and that because it's a point on the x-axis. Okay, up here we have our y-intercept, And why is it our y-intercept? Because x is 0. All right? And that's a point located on our y-axis. All right? So those points are always big to remember, your x and y intercepts. Don't forget those. All right. Let's turn this sheet over. Remember, again, at any time if the clock goes off for our break, just make sure that we pause the video. All right, so now we're moving on to the back of the sheet here in part C. Okay, so part C, we're going to take what we've done in part 1. We're going to apply that. So in part C, you're given two graphs that you see here. Y plus 10 equals 10 and negative 2x plus 2y equals 6. So the 4 dots you see up top, this is what you're going to do in this part here. It says find 5 solution pairs to the equations below, including some negative values. Okay, so pick negative values for x and solve for y. Plot the points on the coordinate grid and draw the graph showing all the solutions. So you're going to plot the points on these graphs. Determine the x and y intercepts from the graph, which you'll write below where it says x and y intercept right here. Okay. And do you notice any patterns or relationships for the x or y intercepts? So as a group, again, we're going to take about 10 minutes to work on this. Okay, you're going to come up with 5 points that make those equations true, just like we did in the very first part. That they all equaled 600. So for the first equation, they better all equal 10. All right, and so on. So I want you guys to pause this video, take about 10 minutes, and then when you're done, I want you to unpause it. And we'll see how you did, and then we'll get going with the final part and be ready to wrap this up and give you your homework assignment. So go ahead again and pause the video. All right. So we're going to shrink this again, and now we're going to see how you did with your points you came up with. Again, now the points that I'm going to show you might be a little different. All right. So because this graph is a little different, it's going to be hard to show because our range. I know it said some negative values, but don't worry. So if I plug a 5 in for x, y is 5 because 5 plus 5 is 10. So we can have 6 and 4, 8 and 2, 3 and 7, 1 and 9. If I go ahead and plot those points, okay, 5, 5, which is right there in the middle, 6 and 4, 8 and 2, 1 and 9, which is way up there, 3 and 7. Okay, so, and again, there's our line. Okay, so again, what is our x and y intercept? Well, again, if I'm trying to find my x-intercept, okay, whenever I find my x-intercept, y is 0. So to find my x-intercept, if I plug a 0 in here for y, all right, I get x plus 0 equals 10. So what does that solve for x? Right, 10. So if y is 0, x has to be 10. So our coordinate is 10, 0 for the x-intercept. Okay? And just the vice versa, when I'm trying to find the y-intercept, x is 0. So by doing that, the x-intercept here, or the x is 0, y is 10. And we write that as 0, 10. Because don't forget, in a coordinate system, everything is written as x, y. X first, y is second on the coordinate point. Okay? So that's what that line looks like. So it was hard to come up with some negative values here with the way the equation was. We kind of lost the range. So I'll tell you what, we'll come up with some negatives for the second one and see how you did. Now again, your points could be different than mine. That's okay. All right? But I guarantee you our line looks the same. So if you had some negative points, they're down here. The only way our lines don't look the same is if you had some miscalculations. And you got to make sure your math is correct here. You know, if you put in a negative 2 for x, that means y's got to be 12, and that obviously puts a point way up here somewhere off the page. Okay. All right, so let's go over the second one and see how you did. I'm going to put some points in here for x. All right. So to do that, if I plug in a negative 2 in for x, okay, I get negative 2 times negative 2 is 4. And when I subtract 4 from both sides, And I'm gonna do my work up here. All right, so if I plug a -2 in for x, okay, I get 4 plus 2y equals 6. If I subtract 4 from both sides, I get 2y equals 2, which means y equals 1. So at -2, 1, my point is right there. Okay, -2, 1. In this point in time, since I know my graph, I should be able to manipulate it to where I can get, hopefully, some intercept points in here. So let's try one. Let's try we have a 0 here, which means this is our y-intercept. So if I plug a 0 in for x, okay, this whole number right here is 0. I'm just left with 2y equals 6. Well, if I divide both sides by 2, y equals 3. So there's my point right there. All right, so let's erase that. So we found a y-intercept. All right. So if I take a -3 and plug it in for x, -2 times -3 plus 2y equals 6. So this is 6. And when I subtract 6 to both sides, I get 2y equals 0. So y here is going to be 0. So that when I plugged in a -3, I get 0. And why? I think I put my 1 point up a little too high on that first one, didn't I? Yeah, -2, 1. I'm a little off there in the middle. So you probably caught that a little before I did, and that's good. So I'm supposed to be at -2, 1, which should be about right there. It's kind of hard to see on my screen. My lines are much more faded than yours are on your paper. All right, so I at least fixed it. Now my line looks a whole heck of a lot better. All right, so let's plug in 2. So if I take -2 times 2 plus 2y equals 6, this is -4. Okay. And I have to add 4 to both sides to get rid of it. So I get 2y equals 10. And if I divide both sides by 2, y equals 5. So my next point's at 2, 5, right there. So again, still looks like I'm lining up real nice. Okay. So I'm finding out my points here. And if I plug a -1 in for here, I get -2 and I add it over. -2 times -1 is 2. So 2 plus 2y equals 6. All right. And if I subtract 2 to both sides, 2y equals 4. Divide by 2, and y is going to equal 2. So that's not right. All right. Well, again, hey, worst case scenario, when you make a mistake, let's erase it and try to retrace. So if I plug in a -1 for x, okay, -2 times -1 is 2, plus 2y equals 6. 2y is going to equal 4. So at -1, 2, I'm right here. So I guess that it was there, just somehow that was looking different. I am here late at night on a Monday night, by the way. So, all right, so we're erasing this. Well, we got our lines, our points here line up, don't they? Pretty much. So we're going to connect the dots. There's our line. That's probably the straightest line I'll draw all year, to be honest with you. Okay. Well, so again, what's our x-intercept? Well, that's when y is 0, right? Well, where's y 0 up in our chart? Is it we got a point? We do, right there. So the point -3, 0 is our x-intercept. The y-intercept is when x is 0, and that right underneath it is that point. So we got 0, 3. So if you look in the first equation, the intercepts are basically opposite the number of each other, aren't they? All right. Where the x and y-intercept in the second one are basically negatives of each other, negative opposites, right? -3 and 3. All right. So that's where they are opposite. So hopefully you did pretty well in that. All right, we are almost done. You guys are trudging through this, doing a good job. All right, the very bottom here. So we're going to expand this a little bit. All right, last thing is called writing it into equivalent form, okay? Which basically means when we write an equation in the equivalent form of the equations below, where y is isolated on the left side, there's a name for that equation. This is what it's supposed to be, okay? Who remembers what the name of it is? Right, this is slope, intercept, form, the equation of a line. So we are going to take this equation here, y plus x plus y equals 10, and put it into a y equals, okay, which we can basically have it as slope intercept form. All right. So if I have x plus y equals 10, and I want to get the y all by itself, I got to move the x over. Well, if you notice, the x is positive, so to get rid of it, I got to do a minus x. Okay. So here I get y equals, and I can't subtract x from 10 without getting a number, right? This just becomes negative x plus 10. And I write the negative x first because of our y equals mx plus b. All right. So now that I got the equation in slope-intercept form, and again, if you were, would you be wrong if you wrote it like this? Absolutely not. So remember, though, from finding this, we can find our slope, which is our m, and our slope is the number that's in front of the x, which is negative 1. And we can also find our b, which is our y-intercept, and that's the number after the 10, which is 0, 10. Remember, we always refer to the y-intercept or the x-intercept as a coordinate. Okay. Now, if I do the same thing with the other equation that we graphed, okay, I'm going to draw a line here to separate these two guys. All right. Okay, so if I take negative 2x plus 2y equals 6, again, I got to move it over and solve for y. So I'm going to move the 2x over and get 0 over here. So I'm left with 2y equals 2x plus 6. Well, remember, it says y is isolated. That means y is by itself. I don't have a y yet. I have a 2y. So let's divide everything by 2. And by doing that, I get y equals, because 2 divided by 2, it's not 0, it's 1. So here I get x plus 6 over 2 is 3. All right? And again, I know by slope-intercept form, when I look at this, I get a slope, the number before the x is 1, so our slope is 1, and our y-intercept is at 0, 3. All right, so let's answer the summary here on the back. All right. How is the solution of a two-variable equation different from a one-variable equation? And that's, again, the one variable has one solution, and the two variable has multiple solutions. Two variable solutions come in, that is, ordered pairs. They are points on a graph. And remember, we write an ordered pair as x comma y in that order. There are blank solutions to a two-variable equation. Infinite or many. Infinite means it never stops. Those lines go on forever. They don't stop. All right. The graph of a two-variable equation in the form ax plus by equals c will be, this is linear. Okay. As we saw in our graphs, this equals a straight line. Okay. And then one of our last examples here. And I know I'm kind of getting into crunch time here because they tell me I had to kick me out at 11:54. I'm sorry, 10:54, and I'm at 10:49 right now, so I'm in a crunch right now if I sound like I'm rushing myself. The intercepts will show you values which will make the x or y equal 0. Remember, an x-intercept gives you y 0. A y-intercept gives you x equals 0. All right, so that is basically our lesson for today. Now, again, depending on what we got done, Your homework that you can work on is this, and that is page 13, number 2, and page 17, 35. Only do A and B in 35. All right, and you can take that class time and work on it now. We're going to end this video.